Hi class. So I'm going to walk through how to solve the quiz problems, and then the second video I'm going to walk through a second problem that will explain some of the mechanics of doing the valuation of a company with the horizon value. So there'll be two separate videos for your reference. First, I'm going to walk through the quiz. I'm going to begin with question 1. And the question asks us if Treasury bills yield 6% and the market risk premium is 9%, then with a beta of 1.5 would be expected to yield what? And I have here the CAPM formula because when we are trying to solve for what we think a stock would be expected to yield or expected to return, those are similar questions, we want to use the CAPM formula. So based on that, I have my solving structure here, and in each of the placeholders I can fill in the information from the problem. So I'm told that the Treasury bill yields 6%, and that is the risk-free rate. So generally, if we're looking for the risk-free rate, we'll use the Treasury bill as our proxy. I'm also told in the problem that the market risk is 9%. Well, RM is not the market risk premium. In fact, M is the market rate of return. So the market risk premium is RM minus RF. So I know that that's 9%. If I want to know what the market risk premium is, and I had the market rate, then I would subtract the market rate, the risk-free rate from the market rate to get the market risk premium. Well, since I have the market risk premium, I'm just going to go ahead and use that number. And then I'm told that the stock has a beta of 1.5. Therefore, I can calculate the problem. And the formula, if you want to solve this on your own, it would be the risk-free rate, 6%, plus the market risk premium times the beta. And that will give you the CAPM. So we would say that this stock is expected to yield a beta, or expected to yield 19.5%. Just the way that Moodle is set up, I'll go through everybody's quiz manually. If you entered 0.195, that would be correct. If you entered it as 19.5%, Moodle will tell you that you have an error, but that is in fact correct. There's just a formatting difference. So I will be going through and adjusting anybody's score if that happens. That's question 1. Question number 2 then, if we take a look at that, we have some information and we want to know what the company cost of capital is after tax for a firm with 65-35 debt and equity split, 8% cost of debt, 15% cost of equity, and a 35% tax rate. So this problem allows us to use the WACC equation. So this is for the WACC. And in this question, we have some information provided to us. There's some information that's missing, but we actually don't need it. So in this problem, we're not given the market values of debt, preferreds, and common stock, but we are given their percentages. So it tells us that we have a 65% debt and a 35% equity split. We're also told that the debt has an 8% cost of capital, and the equity is 15%, and then we're given the tax rate that is 35%. So given that I already have my structure for the WACC set up, I can calculate the WACC at 8.6%. And if you want to know how that works, I'm going to ask you to go into the Excel and look at calculations are done. The one that I will point out is this ATC of C. That means after-tax cost of capital. And what I do in that equation is I take the cost of capital times 1 minus the tax rate. And that gives us the after-tax cost of capital for the debt of 5.2%. So generally, for debt, if you have a tax rate, that number right here, the after-tax cost of capital that I'm highlighting in pink, should be lower than the cost of capital. If you don't have that, then you've probably done something wrong in your calculation. And then the weighted average cost of capital is simply the after-tax times the percentage of the market value. And again, if you entered your number in a way that made Moodle mark it incorrect, I will go through and look at it and make sure that you get full points. Great. So now we have number 3. The company has 2 million shares of common stock outstanding, and the stock trades for $3 per share. It also has 2 million in debt. What is its ratio of debt to value for WACC purposes? What this question is asking us is if we take debt divided by value, what is the percent? So if we take the total amount of debt times the total value of capital for the company, what is that percent? I have a simple schedule set up here where I have debt and equity in each row. And for the debt, I'm going to enter in $2 million because that's the value of the debt. For the equity, I'm going to enter the shares, 2 million shares. Oops, I forgot a 0. I'll add one additional 0. And then I'm going to enter the share price, $3. Now when I multiply those together, I get a value of 6 million. Therefore, when I add together the 2 million in debt and the 6 million in equity, I get a total of 8 million. And then to determine the value of debt divided by the total value, I just take 2 million divided by 8 million, and that gives me 25%. That's what we're looking for in this question. If I were doing the full weighted average cost of capital, that 25% would be placed as the value as the percent of total for that particular item of capital, which in this case is debt. Great. So now we're going to look at the fourth question, which has to do with a company valuation and determining the horizon value. In order to solve this problem, I've set up a small template. And what I have in here is a field where I've placed the weighted average cost of capital, which is 12%. And then I've set up the number of years, 1, 2, 3, 4, and 5. And then I have a row, the green row, where the values will be for the cash flows that are given to us. So I'm going to type those in. 1 million, 1.25, 1.5 million, 1.75 million, and 2 million. I'm going to set up those cash flows. This analysis is very truncated, and so what it means is that we've left out the full evaluation of the cash flows. You're just given the net cash flows. Now let me walk you through what we do to determine the horizon value. The problem tells us that after year 5, the firm is going to grow at 5% per year indefinitely. This gives us two pieces of information. The first is that the growth rate is 5%. Secondly, it's indefinitely, which tells us that it's the horizon value, and then that also tells us that this is a perpetuity, because forever means a perpetuity, indefinitely means forever. What I do then with that information, going back to my spreadsheet, is the following. I take the prior year, which is year 5, and those cash flows, and I'm going to increase them by 5%. So to do that, I will take the 2 million times 1 plus that growth rate of 5%. What that means is that the horizon value cash flow, the single cash flow, is 2.1. Now what I have to do is take the 2.1 and calculate the perpetuity. To do that, I use the equation cash flow divided by R minus G, where R is the weighted average cost of capital. That gives me the present value of the horizon value at the end of year 5, which is also the beginning of year 6. That's really important because that $30 is not in present value terms. So I'm going to come back to that. Now what I do is calculate the present value of each one of those cash flows. Let me set that up. I'm going to use the present value function. I'm going to use 12% as the rate. The number of periods is the year. So in this case, it's year 1. And then the cash flow is the future value. I'm going to hit enter. Now I'm going to do two things to this equation. Because these cash flows are positive, I need the present value to have the same sign as the cash flow. In order to do that, I'm going to place a negative value up in front of the PV equation. Now my present value is positive. The second thing that I'm going to do is I'm going to place dollar values, or dollar symbols is probably a better way to say it, in front of the column and the row where the WACC is. Because now I'm going to take this present value equation and I'm going to copy it across. And I don't want to copy it into the horizon value column. I'm going to do that present value equation on its own. I did just copy it and I deleted it because the value's on a different row, and also I need to use the proper number of periods. Let me set up the present value calculation again. The rate is going to be the same, 12%. The number of periods is going to be the last year that we have in our calculation. And that is because that $30 is the present value as of the end of year 5. The $2 is also as of the end of year 5. And that's just a norm of how this analysis works based on the way that the present values calculate and the way that the perpetuity equation works. The future value then for the horizon value is the 30. And then I have to remember to put my negative sign in front of the present value again. Therefore, when I add those values together, the present value of the entire business should end up being 22.23. Doing this calculation to value the business, it is, again, very similar to doing a project. It just has a couple of different characteristics. So one It's total cash flows, not incremental. Also, we have this thing called a horizon value. That has a special treatment because that horizon value is representative of the continuing value of the business, and it's a perpetuity. We have to do two things to get the horizon value calculation. The first is we take the last year's cash flow and we increase it by the amount of the growth rate, and then we calculate the perpetuity. Cash flow divided by R minus G. Then the final thing that we have to remember when we're calculating the present values of each of the cash flows, we actually have to calculate the present value of that total horizon value, the perpetuity value. And we do that using our standard present value, and then we use as the NPER the final year where we had our last cash flow. So 5 in this case. This gives you a view of how we work, the general valuation for a company. The next video that I'll do will show you a little bit more about how to do this with some more detailed information, but we'll also get another chance to practice looking at the horizon value and how to calculate that.